Okay, so in this session, I'm going to talk about exceptions. I'm going to let you know that what is exceptions, what are some examples of exceptions, how we can handle the exceptions, and some other important points about exceptions and some simple examples in exceptions. Okay, let's see what is exceptions. In this session, I'm going to talk about exception. So actually, the exception is an object that represents an error or exceptional event that has occurred. So these type of errors can happen because of runtime environment that has detected an operation that is impossible to carry out. It's good to know that all of the exception objects are children of throwable class. So there is here some examples of exceptions. For example, index out of bounds exception. What is this exception? When an array index is out of bounds, or file not found exception. It happens when you are trying to open a file that does not exist. Or for example, no such method exception. That's a kind of method, that's a kind of exception that happens when you as a programmer are trying to call a method that does not exist, right? So these are some examples of exceptions. So if we want to categorize exceptions, we can categorize them into groups: normal exceptions and runtime exceptions. Normal exceptions or checked exceptions, these type of exceptions are the ones that you need to take care of. So you need to handle them. It means you need to catch them or declare that your method can throw them. For example, file not found exception is a normal exception. Another group of exception is runtime exceptions or unchecked exceptions. These type of exceptions are the ones that you do not need to handle them, right? For example, index out of bounds exceptions. So if you, for example, are trying to, for example, retrieve a value in an array with an index that is out of bound, right, in your program, then index out of bound exceptions will happen, and you are not the person who is going to handle this exception. We have a class of exceptions that is called errors. For example, virtual machine error is one of these exceptions. And these type of exceptions do not need to be handled, right? So here you can see some common built-in exception types. For example, class not found exception. This type of exception happens when you are trying to use a non-existent class. Or clone not supported exception. That's another type of exception that happens when you are trying to call the method clone for an object that doesn't implement the clonable interface. We have talked about clone and clonable in the previous session, so you remember what they mean and what they are good for. Or another exception is, for example, runtime exception. Right. So this type of exception happens when, for example, we have arithmetic exception or null pointer exception or index out of bound exception. So when any of these exceptions happen, then the program aborts, right? Another type of exception is IO exception. As you see, based on its name, it's a type of exception that happens when we have an input-output errors. An AWT exception is another type of exception that happens when you have graphics programming errors. So these are some built-in exceptions that, by default, the Java take care of them. But you as a programmer can create some other exceptions based on your need. But you need to keep in mind that these exceptions that you are going to create needs to be derived from class exception or from one of its subclasses. So now you know that what is exception. You know that exception is actually is object that represents an error or an exceptional event in the program. That exceptional event, for example, can be when an index is out of bound, when a file doesn't exist, when a method that is called doesn't exist, or some other exceptions. We saw that we have some built-in exceptions, right? Like class not found exceptions when we, in our program, calling a class that doesn't exist. So this type of exception happens and our program can handle it well. And I told you that we also can create some other type of exceptions that are not built in. So now maybe this question comes to the mind that why do we need exception? So actually, exceptions are used to make our program more robust. You know that if an exception happens and your program doesn't be able to handle that exception, then the program will be terminated unnaturally. And that's not good for some of the systems. Like what type of systems? Java was originally a language that used to be used for example, embedded systems like TVs, phones, and watches. And you know that these type of systems should never stop working. So it's important that this language be able to detect the exceptions and be able to handle the exceptions, right? So that's why we need exceptions. So let's see some examples that in the example, the exception has been detected and some other example that in that example, the exception has been handled. Okay, let's see a very simple example. So in this example, we have public static void main we have x and y, and we are going to get these two from user, right? So we need to import java.util.scanner. So scanner input B new scanner system.in. And we are going to print a message to the user so that the user will be notified to enter the X as the input. So system.out.print, type the numerator, right? And we are going to save the input inside the variable X. So input dot next int, since it's an integer. Okay, so that's the first number. So that's the numerator. So in this example, we have a numerator and denominator. So I want to show you that you know that in mathematics, when the denominator is a 0, that's an error, right? So I want to show you how Java handles this type of exception. So system.out.print type denominator YB input dot next int. And finally, I'm going to print system.out.print ln x divided by y is this value. So let's see what will happen if we run this example. So as you see, this program crashes because of division by 0, right? Now let's try another example. Okay, in this example, that's the same as the previous one, but we are going to see that, we will see that this program won't crash when the exception happens, but the exception will be handled. So again, we have X and Y. Scanner input be new scanner system.in system.out.print type numerator we need to import java.util.scanner. xb input dot next int yb input dot next int. So try system.out.println so we are going to see if we catch the exception, then we will handle the exception. And if no exception happens, then we are going to do the division, right? So before system.out.println after, right? So if we catch the exception, we are going to print error, right? And if no exception has been catched, then these lines of code would be executed. So here we are going to see how actually the exception handling is handled. So this process involves 3 steps. The first step is claiming the exceptions. What it means by claiming exceptions? It means for each method, we need to specify what exceptions may happen, right? What are the exceptions for that method? The next step is throwing an exception. It means when an exception happens, then we need to create an exception object. We need to throw that. And the last step is catching an exception. It means the appropriate handler catches and thrown exception, right? And then by catching the exception, it will perform blocks of code. So these are 3 steps for exception handling. So as I mentioned, the first step for exception handling is claiming the exception. It means for each method, we need to specify what exceptions we expect to see, right? So in order to implement the claiming exceptions, you can use the keyword throws. And after this keyword, you should list the name of the exceptions that can happen inside your method. Here you can see 2 simple examples. For example, we have 2 methods, my method and your method. In my method, you expect to see, for example, the exception, input-output exception, right? IO exception. So what you need to do is write public void my method, right? And then the keyword throws, and after this keyword, you need to write the name of that exception, here IO exception, right? So now, it's by writing this, you say that you expect this type of exception happens inside your method. Or for example, you have a method with the name your method, and you expect to see some exceptions, right, in like input output exception, or for example AWT exception, or for example one exception that you have created and its name is, for example, Bob exception, right? So what you need to do is write public void your method, right? And then use the keyword throws, and after that you need to list the name of those exceptions. IO exception, AWT exception, and Bob exception. For example, this is one exception that you have created. That's not a built-in exception. So that's how you can claim the exceptions for your methods. Okay, the next step for handling the exception is throwing the exception, right? It means, as I mentioned before, each exception is an object, right? So you need to create the exception and then throw the exception. How? By using the keyword throw. So keep in mind that this keyword throw is different from the previous keyword that I mentioned. That one was throws. And throws is used to claim the exception, but throw here is used for throwing the creating, and then when we want to create and throw the exception, we use this keyword, right? So how? I told you the exception is object. We need to create the object and then throw that object with the keyword throw. So you can do that all in one line. For example, throw new, the name of that exception here is bad hair, for example, day exception, right? Or you can do that in, for example, two separate line of code. For example, my exception M be new my exception. So now you have created one object of my exception with the name M, and then throw M. You are throwing this object, this exception. Or for example, if this condition happen, person on phone is not Bob, for example, then throw new exception, right? So as I mentioned before, you need to keep in mind that throw here is different from throws that we had in the previous step for claiming exception. Okay, let's see the actual format for exception handling and catching the exception. So first we have try, right? And then followed by try, we may have several catch. And finally, we have finally. First, let's see what is try and the try block. So inside the try block, we have all of those statements that is going to be executed, right? And they may throw an exception. So these statements are actually lots of I/O code opening and reading from or to files. They can have so many of these lines of code, right? Then we have several catch. So each catch can catch one exception. So for each catch, we have one parameter, and that parameter is actually that exception that has been catched, right? If that exception has been catched, then the statements inside the opening braces and closing braces would be executed. For example, this can be a message, right? It will let the user know that this type of exception has happened. So as you see here in this example, we have several catch, three catch. The first one is checking file not found exception. The second one, EOF exception and the file exception. And the third one, IO, input output exception. And as you see, we have at the end the finally keyword. This part is always executed, no matter we have an exception or not, no matter how the try block will be left, right? So this part, just keep in mind that the finally block will always be executed. This part, because it makes sure whether we have any make sure to close all of the files that can be opened. So this part is the part that always will be executed. So that's actually a very simple example that shows you what is the format for catching the exception. So we have try, we have several catch, and then we have finally. So let's see what exactly happens when an exception is not caught. So actually, if you have a method and that method doesn't catch a checked exception, then the compiler will complain, right? The compiler will show a message about that. If you have a method and that method throws an exception, then you call that method inside another method. Then the method that called the first method also need to handle the exception or declare that it can throw that exception, right? That's very obvious. And if no method handles the exception, then the program crashes, right? And you will see a message about that. That's exactly the same for unchecked exceptions. But the only difference between checked exceptions and unchecked exceptions is that checked exceptions must be handled. We have another concept, rethrowing exception. What it means by rethrowing exception? You know, sometimes it's really hard to handle exceptions, right? It's tedious. And as I mentioned before, you can create some exceptions that are not built in, some unchecked exceptions. So when you have some unchecked exceptions, then you need to handle them as well, right? Here, there is a good news for you that you can rethrow the checked exception as an unchecked exception. That's very easier. So for example, as you see in this simple example, you catch an unchecked exception and then you throw the checked exception, for example, runtime exception here. So as you see, the handling of this unchecked exception is way easier. Instead of writing down separate codes for handling this unchecked exception, you could rethrow a checked exception. Okay, now that you know what is exception, how you can handle exception, what is the good format for the code of exception handling, maybe you have this question that when can you use the exception? Whether you can use, for example, exception for all of the error checking tasks or not. Okay, the answer here is that you should not use exceptions for all of the error checking tasks. For example, you may want to validate the user input, right? Check whether it's like in appropriate format or such things. That's a very simple example. It's better that you don't use exception for this example. Instead of exception, you can easily use a very simple if statements and loops, right? So exceptions are good for handling the errors that result in the termination of the program, right? So you see that you need to use the exception for those types of error that really do need to be handled because if you don't handle them, they can cause a serious problem for your program. In this slide, you can see some of the links for checking the examples in exceptions. These examples are from the detail book, so easily you can click on the link and see all of the examples. You can try these examples and practice more.